Okay, so welcome back, and now we're going to do an example, and here's the triangle that we're going to solve. And so they want us to solve for the unknown sides and the unknown angles for this triangle. Now the first thing you notice is that we've got these two sides and the angle between them, so the included angle, okay? So that's what we call the included angle. So this is a side angle side triangle, so this is a candidate. This is one of the situations where we are going to use the law of cosines. So let's do that. So now, how do we do this? We want to solve, so the first thing we do is we want to solve for the unknown side. Okay, so that's going to be b. So we're going to use the formula that says b squared is equal to what? C squared plus a squared minus 2ac cosine theta, where theta is the angle between the two sides. Okay, so now all we have to do is plug and chug. So c is 12, so that's going to be 12 squared plus a squared, a is 10, minus 2 times a, which is 10, times c, which is 12, times cosine of 30 degrees. Okay, so now this gives us 144 plus 100 minus 240 times cosine of 30 degrees. Well, what's the cosine of a 30-degree angle? That's going to be the square root of 3 over 2. Okay, and so now if we stick this in our calculator, we get what? Approximately 6 point, well, we get more than that, but here we get, this is b squared, right? So if we simplify this, we get 244, right? So this is 244. Okay, 244 minus 240 times the square root of 3 divided by 2. And of course, if we take the square root of both sides, and again, the fact that we're dealing with triangles, lengths are always positive, so we don't have to worry about the plus or minus. So we can say b is equal to the square root of 244 minus 240 times the square root of 3 over 2. Okay, and so if we stick this in our calculator and take the square root, we get approximately 6.013. 6.013. And that's for b. So we're going to put 6.013. Okay, now that we got the side, now guess what? Now we can use the law of sines to complete the remaining angles of the triangle, right? So now the cool thing is once we found this side, now we can use the law of sines to figure out the rest, okay? So we can use this with this and either one of these signs to solve for one of the other angles, right? So now we've got all three sides, right? Now all we need is to solve for one of these two angles, and then we can just use the fact that three interior angles of a triangle add up to 180 degrees, and we're done. So let's, it doesn't matter which one we solve for, let's solve for angle C. Okay? Or angle A, let's do angle A. Okay? So angle A, how do we do that? Well, we're going to do sine A, right, over A is equal to sine B over B. Well, now all we have to do is fill it in. So it's going to be sine A over A, which is 10. And sine B, oops, that's what we're solving for. Sine B over B, which we just solved for, which is approximately 6.013. Oh no, we do know B. B is 30 degrees. Okay, So now all we have to do is solve for a. So multiply both sides by 10 and we get sine a is equal to 10 sine 30 degrees divided by 6.013. And so if we take the inverse sine of both sides, we get a is equal to sine inverse of 10 times sine of 30 degrees divided by 6.013. And so angle A turns out to be approximately 56.3 degrees. 56.3 degrees. Oops. Okay. Now, again, we have to look at possible other triangles, right? So we could have 180 minus 56.3. Okay, now looking at the diagram, this angle here is adjacent the longest side. Right? So, if we swing this side here, right? So again, if we swing this side, there could be a possibility of two possible triangles. So, if we take 180 degrees minus the 56.3, that gives us 123.7 degrees, right? Yes, 123.7 degrees. Okay. Now, the thing is since this angle is along the longest side, remember, the longest side is going to be across from the longest angle. Well, if we look at this here, this is bigger, right? So this angle would be, so if this was 123.7 degrees, right? Then that would mean that this side would be the largest angle, because if this is 30, right? And this is 123.7, well, then that would make sense. Okay, so that's why we're going to stick with 56.3 degrees. Okay, now, let's see here. Okay, so is there anything else that I want to say? Okay, so now the other thing to notice is that if we were to, instead of use the law of sines, if we were to use the law of cosines, now that we have this angle, we could use this side and this side, and well, let's see here, and this angle, and we could get unique sides. Okay. Okay, and the reason why it's unique is because it gives us unique answers between 0 degrees and 180. So, if we proceed with the 56.3 degrees, then guess what? We're pretty much done. Because like I said, all we have to do is just add these two, right? And we get what? We get 86.3, right? So we get 86.3. And so if we subtract 186.3, or excuse me, 86.3 I should say, from 180, that gives us 93.7 degrees, right? And so that means C is 93.7 degrees. And now we have our 3 sides and our 3 angles calculated. Have a great day.